Increasing or decreasing functions are called monotonic functions. Let us see the definition of an increasing function. If we are given a function f of x, then this function is called an increasing function in the interval a comma b if we take any two numbers, let us say x1 and x2 from this interval a comma b such that x1 is less than or equal to x2 implies that f of x1 is less than or equal to f of x2. So if this condition is satisfied, we shall say that the function is an increasing function. If there is no equality, then f of x is called strictly increasing function. Let us see the graph of these functions. I am taking a point x1 on the x-axis and another point x2 on the x-axis. Let us draw the graph of a function f of x. And now let us draw the point f of x1, which is this distance from x-axis to the graph of the function. And f of x2, which is the distance from x2 to the graph of the function f of x. Now from here we can see that x1 is less than x2, but we can see from the graph that f of x1 is also less than f of x2. So this is called an increasing function. It goes from down to up. Now let us draw another graph. Here again I am taking a function. It goes like this one, then here and so on. Now this one is f of x. Let us take some points. This is point x1 and now let us say this one is point x2. There is another point, let us say x3, and also draw the distance here and also from this point to that place. So we can see that x1 is less than x2, and this implies that f of x1 is less than f of x2. Now again, x1 is less than x3, but we can, x2 is less than x3, but we can see that f of x2 is equal to f of x3. So such types of graphs or functions, they are called increasing functions. In a similar way, we define decreasing functions. If we are given a function f of x, then this function is said to be decreasing function in some interval a comma b if we take any two numbers from these intervals a comma b such that x1 is less than or equal to x2 implies that f of x1 is greater than or equal to f of x2. Then this function is called a decreasing function. Let us see the graph of these functions. So again, let us say this one is x-axis and this one is y-axis. And I'm taking any 2 points, x1 and another point, x2. And now let us draw the graph. of the function f of x, which is like this one. From x1, the distance to the graph, that is called f of x1. And from x2, the distance to the graph is called f of x2. So we can see that x1 is less than x2, but f of x1 is greater than f of x2. So this is a decreasing function. The graph of the function comes from up to down. Let us see another graph. In this graph, we have a function like this one. Let us say this is f of x. Now take any 2 points, x1, and find the distance here. This one is now f of x1. Take another point, x2, and the distance, which is f of x2. Take another point, x3, and the distance is, of course, f of x3. So we can see that in this graph, x1 is less than x2, but f of x1 is equal to f of x2. However, x1 is less than x3, but f of x1 is greater than f of x3. So this graph is also a decreasing graph of some function. So the function is decreasing. Again, if there is no equality, like we say f of x1 is greater than f of x2, then f of x is called strictly decreasing function. Constant functions. If we are given a function f of x, then this function is said to be a constant function in the interval a comma b if we take any 2 points x1 comma x2 from the interval a comma b such that f of x1 is equal to f of x2, then we say that f of x is a constant function. Let us see the graph of a constant function. This one is x-axis and this one is y-axis. Now, if I take any 2 points, x1 and x2, and let us draw the graph of a constant function. Let us say this is f of x. Now, the distance f of x1 and this distance from x2 to the graph, which is called f of x2, we can see that f of x1 is equal to f of x2. Similarly, if we take any 2 other points, again, the value of the function at those points must be equal. So these type of functions are called constant functions. We say that a point x is equal to c is a critical point of a given function f of x. If we differentiate that function and then put the value c in that function, and the answer is 0 or undefined, plus infinity or minus infinity. In that case, c is a critical point of f of x. We shall use this test to find the interval in which a function is increasing or decreasing. If f dash of x is less than 0 for all x belongs to some interval, let us say a comma b, this will imply that f of x is a decreasing function. Function in the interval a comma b. Number 2, if f dash of x is greater than 0 in the interval a comma b, this will imply that f of x is an increasing function in the interval a comma b. Number 3, if f dash of x is equal to 0 in the interval a comma b, this will imply that f of x is a constant function in the interval a comma b. Let us solve example number 1, in which we shall find the critical points interval of increasing and decreasing for this function f of x. So the first step is that we shall differentiate this function. So f dash of x is equal to 3x square minus 3. And if I further simplify this by factorizing, we can get 3 into x minus 1 into x plus 1. Now for the critical points, we shall put f dash of x equal to 0, which means 3 into x minus 1 into x plus 1 is equal to 0. From here we get that x minus 1 is equal to 0 or x plus 1 is equal to 0, which gives 2 points. X is equal to 1 and the other one is x is equal to minus 1. So we have 2 critical points. Now let us find intervals in which f of x is increasing. So we know that f of x is increasing if f dash of x is positive. So now let us put value of f dash of x, which is 3 into x minus 1 into x plus 1 greater than 0. From here we have x minus 1 into x plus 1 equal to 0. Now the product of these two guys is positive, which means the first one is positive and the second one is positive, or the first one is negative and the second one is negative. So there are two cases. Case number 1 is that x minus 1 is positive and x plus 1 is also positive. That is why the product will be positive, which gives x is greater than 1 and x is greater than minus 1. Now let us draw these points on a graph. Let us say this is 0, this one is 1, this one is minus 1. The first one says x is greater than 1. So x is greater than 1 is this one. The second one says x is greater than minus 1. Now the common region of these two is x is greater than 1. The common region. And this implies that the interval is from 1 to infinity. Now let us consider case number 2. Case number 2 is that the product is positive, x minus 1 into x plus 1 is positive. If x minus 1 is negative and x plus 1 is negative, from this we get x is less than 1, and from this one we get x is less than minus 1. So now let us draw this on a graph. So we have this is 0, this one is 1, and this one is minus 1. So the first one says x is less than 1. So it means it is this line, x is less than 1. The second one says x is less than minus 1. Now again we have to take the common region. The common region from this graph is x is less than minus 1, which means the interval is from minus infinity to 1 to minus 1. Therefore, f of x is increasing on the interval minus infinity to minus 1 and in the interval from 1 to infinity. Now let us find the interval in which the function f of x is decreasing. Since we know that f of x is decreasing if f dash of x is less than 0, let us put the value x minus 1 into x plus 1 is less than 0. Now the product of two things is negative, which means that again we have two cases. Case number 1 is that the first one is negative and the second one is positive. From this we get x is less than 1 and x is greater than minus 1. Let us draw on a graph. This is 0, this one is 1, this one is minus 1. So x is greater than minus 1 is now this line, and x is less than 1 is this line. The common region of these two lines is minus 1 to 1. So f of x is decreasing on this one. Let us see case number 2. Again, x minus 1 into x plus 1 is negative, which means that now the first one is positive and the second one is negative. From this we get x is greater than 1, and from this we get x is less than minus 1. Let us draw these points on a graph. This one is 0, this one is 1, and this one is minus 1. X is greater than 1 is now this line, and x is less than minus 1 is this line. So we can see there is no common region. So the only interval at which f of x is decreasing is minus 1, comma 1. Let us solve this problem with another method. As usual, we will take f dash of x, and for the critical point we have to put f dash of x equal to 0 and we can get x is equal to 1 and x is equal to minus 1 as two critical points. Now, after getting the critical points, represent these points on a real line, just like -1 and 1. And now, from here, we can find three intervals. The first interval is this one, which is from -1 to -infinity. The second one is this one, which is from -1 to infinity. And the third one is from 1 to infinity. So we have these three intervals. You can see in this table, -infinity to -1, -1 to 1, and 1 to infinity. Now, to find whether these intervals are increasing or decreasing, we shall check the sign of f dash of x. So take any point from inside this interval from -infinity to -1. So let us take x is equal to -2 and put it in f dash of x and simplify this. So we can see we get 9, which is greater than 0. It means it is positive. So f dash is positive in this interval, which means f of x is increasing in the interval -infinity to -1. And now let us consider the second interval. In the second interval, put any point from this interval in f dash of x. So let us take x is equal to 0. When we put x is equal to 0 in f dash of x, we get -3, which is less than 0. It means it is negative. So f dash is negative in this interval means f of x is decreasing in the interval -1 to 1. And now let us see the last interval, which is from 1 to infinity. Take any point from this interval. We are taking x is equal to 2. Put that point in f dash of x. After plugging in f dash of x and simplifying, we get 9, which is greater than 0. So it means that it is positive. So f of x is increasing in the interval 1 comma infinity. So in these two intervals, 1 comma infinity and -infinity comma -1, f of x is increasing, and this one interval, which is -1 to 1, f of x is decreasing. That's all.